everyone. I am Jeremy Canoy. I am your reporter for this day. And my topic is all about forensic chemistry and toxicology. So what is forensic chemistry? Forensic chemistry is defined as the branch of chemistry which deals with application of chemical principles in the solution of crimes. Like other forensic sciences, forensic chemistry plays a very important part in the speedy investigation and in the administration of justice. So next is practice of forensic chemistry. The work of a forensic chemist is divided into four stages, namely, first is collection and reception of the specimen. Second is the actual examination. Third is the communication of the result of the examination. And the fourth is court appearance. Let's proceed to the factors that must be considered when collecting a specimen of examination. First is sufficiency of samples. Second, standard of comparison. Third is maintenance of individuality. And fourth is labeling and sealing. So, sufficiency of samples. As much as possible, the investigation should collect sufficient amount of specimen for examination. This will make the chemist confident that in case of doubtful result, he or she can still have enough samples to repeat or to proceed to the succeeding examination. So second is standard of comparison. When the evidence is questioned, is located in or added with a foreign substance, a sample or such foreign substance must be submitted for analysis. Let's proceed to the 6 golden rules in practices of forensic chemistry. Number 1. Go slowly. Good work cannot be hurried. Therefore, take all the time necessary to make the case complete no matter how urgent it may appear. Number 2. Be true. Make careful and minute examination of everything and do not be satisfied with a quantitative analysis if a quantitative one is possible. It always pays to do too much rather than too little, and it is difficult to foresee what will or will not be required in court. Number 3. Take note. Keep a full, neat, and clean record of everything seen and done. Number 4. Consult others. Many cases will lead the expert into path with which he is not familiar, and when this happens, he should consult those who know better. Number 5. Use imagination. An expert with a wide and uncontrollable imagination is considered as the most dangerous creature. Though his being imaginative is sometimes useful, an expert witness does not have to be solely imaginative, but he has to be skilled in the field of forensic science. He must bear witness within the limits of science. Number 6. Avoid complicated theories. The simplest explanation is fundamentally the right one. Interpretation of result is often the most difficult part of the expert's task. That is why a wide knowledge and scientific experience are the essential elements to obtain the right forensic examination result.
Forensic chemistry is the application of chemistry and its subfield, forensic toxicology, in a legal setting. A forensic chemist can assist in the identification of unknown materials found at a crime scene. Specialists in this field have a wide array of methods and instruments to help identify unknown substances. These include high-performance liquid chromatography, gas chromatography, mass spectrometry, atomic absorption spectroscopy, Fourier transform infrared spectroscopy, and thin-layer chromatography. The range of different methods is important due to the destructive nature of some instruments and the number of possible unknown substances that can be found at a scene. Forensic chemists prefer using non-destructive methods first, to preserve evidence and to determine which destructive methods will produce the best results. Along with other forensic specialists, forensic chemists commonly testify in court as expert witnesses regarding their findings. Forensic chemists follow a set of standards that have been proposed by various agencies and governing bodies, including the Scientific Working Group on the Analysis of Seized Drugs. In addition to the standard operating procedures proposed by the group, specific agencies have their own standards regarding the quality assurance and quality control of their results and their instruments. To ensure the accuracy of what they are reporting, forensic chemists routinely check and verify that their instruments are working correctly and are still able to detect and measure various quantities of different substances. Forensic chemists' analysis can provide leads for investigators, and they can confirm or refute their suspicions. The identification of the various substances found at the scene can tell investigators what to look for during their search. During fire investigations, forensic chemists can determine if an accelerant such as gasoline or kerosene was used. If so, this suggests that the fire was intentionally set. Forensic chemists can also narrow down the suspect list to people who would have access to the substance used in a crime. For example, in explosive investigations, the identification of RDX or C4 would indicate a military connection, as those substances are military-grade explosives. On the other hand, the identification of TNT would create a wider suspect list, since it is used by demolition companies as well as in the military. During poisoning investigations, the detection of specific poisons can give detectives an idea of what to look for when they are interviewing potential suspects. For example, an investigation that involves ricin would tell investigators to look for ricin's precursors, the seeds of the castor oil plant. Forensic chemists also help to confirm or refute investigators' suspicions in drug or alcohol cases. The instruments used by forensic chemists can detect minute quantities, and accurate measurement can be important in crimes such as driving under the influence, as there are specific blood alcohol content cutoffs where penalties begin or increase. In suspected overdose cases, the quantity of the drug found in the person's system can confirm or rule out overdose as the cause of death. Modern forensic chemists rely on numerous instruments to identify unknown materials found at a crime scene. The 20th century saw many advancements in technology that allowed chemists to detect smaller amounts of material more accurately. The first major advancement in this century came during the 1930s with the invention of a spectrometer that could measure the signal produced with infrared (IR) light. Early IR spectrometers used a monochromator and could only measure light absorption in a very narrow wavelength band. It was not until the coupling of an interferometer with an IR spectrometer in 1949 by Peter Felget that the complete infrared spectrum could be measured at once. 202 Felget also used the Fourier transform, a mathematical method that can break down a signal into its individual frequencies, to make sense of the enormous amount of data received from the complete infrared analysis of a material. Since then, Fourier transform infrared spectroscopy (FTIR) instruments have become critical in the forensic analysis of unknown material, because they are non-destructive and extremely quick to use. Spectroscopy was further advanced in 1955 with the invention of the modern atomic absorption (AA) spectrophotometer by Alan Walsh. AA analysis can detect specific elements that make up a sample along with their concentrations, allowing for the easy detection of heavy metals such as arsenic and cadmium. Advancements in the field of chromatography arrived in 1953 with the invention of the gas chromatograph by Anthony T. James and Archer John Porter Martin, allowing for the separation of volatile liquid mixtures with components which have similar boiling points. Non-volatile liquid mixtures could be separated with liquid chromatography, but substances with similar retention times could not be resolved until the invention of high-performance liquid chromatography (HPLC) by Csaba Horváth in 1970. Modern HPLC instruments are capable of detecting and resolving substances whose concentrations are as low as parts per trillion. One of the most important advancements in forensic chemistry came in 1955 with the invention of gas chromatography mass spectrometry (GCMS) by Frederick McLafferty and Roland Gauck. The coupling of a gas chromatograph with a mass spectrometer allowed for the identification of a wide range of substances. GCMS analysis is widely considered the gold standard for forensic analysis due to its sensitivity and versatility along with its ability to quantify the amount of substance present. The increase in the sensitivity of instrumentation has advanced to the point that minute impurities within compounds can be detected, potentially allowing investigators to trace chemicals to a specific batch and lot from a manufacturer. Forensic chemists rely on a multitude of instruments to identify unknown substances found at a scene. Different methods can be used to determine the identity of the same substance, and it is up to the examiner to determine which method will produce the best results. Factors that forensic chemists might consider when performing an examination are the length of time a specific instrument will take to examine a substance and the destructive nature of that instrument. They prefer using non-destructive methods first, to preserve the evidence for further examination. Non-destructive techniques can also be used to narrow down the possibilities, making it more likely that the correct method will be used the first time when a destructive method is used.
So let's proceed to the scientific evidence. So what is evidence? Evidence is a proof of allegation. It is a means sanctioned by law ascertaining in a judicial proceeding the truth respecting a matter of fact. There are three types of evidence: direct evidence, circumstantial evidence, and hearsay evidence. So direct evidence is that which the sense perceived, any fact to which a witness testified based on what he saw, heard, smelled, touched, or tasted is direct. So next is circumstantial evidence. Is a kind of evidence which seeks to establish a conclusion by interference from the facts proven. Or hearsay evidence is the statement made by a witness on the authority of another and not from his own personal knowledge or observation. Next is forms of scientific evidence. First is real or autoptic evidence. Is that evidence which is addressed to the senses of the court. It is not limited to that which can be known by the sense of vision and extend to those which are perceived by the senses of hearing, taste, smell, or touch. Second is testimonial evidence. An expert may be called on the witness stand to answer all questions propounded by both parties in the case. Third is documentary evidence. Any written evidence presented by an expert in court which is relevant to the subject matter in dispute and not included by the rules of court. Formal written report, expert opinions, certificates, and dispositions are included in this group.
Direct evidence supports the truth of an assertion. In criminal law, an assertion of guilt or of innocence directly, that is, without an intervening inference. Circumstantial evidence, by contrast, consists of a fact or set of facts which, if proven, will support the creation of an inference that the matter asserted is true. For example, a witness who testifies that he saw the defendant shoot the victim gives direct evidence. A witness who testifies that he saw the defendant fleeing the scene of the crime, or a forensics expert who says that ballistics proves that the defendant's gun shot the bullet that killed the victim, both give circumstantial evidence from which the defendant's guilt may be inferred. In direct evidence, a witness relates what he or she directly experienced. Usually the experience is by sight or hearing, though it may come through any sense, including touch or pain.
Let's proceed about drugs. Drug is a chemical substance that brings about physical, psychological, behavioral, and/or psychological change in a person taking it. Medicine are drugs, but not all drugs are medicine drugs. So next is medicinal drugs, a substance which, when taken into the human body, cure illness and/or relieve signs or symptoms of disease. So next is dangerous drugs, a substance affecting the central nervous system which, when taken into the human body, brings about physical, emotional, or behavioral changes in a person taking it. Next is drug abuse, any non-medical use of drugs that cause physical, psychological, legal, economic, or social damage to the user or the people affected by the user's behavior. Let's proceed to the classification of drugs. First is natural drugs, are active ingredients, secondary metabolic products of plants and other living systems that may be isolated by extraction. Next is synthetic drugs, are artificially produced substances synthesized by the laboratory for an illicit market, which are almost wholly manufactured from the chemical compounds in illicit laboratories.
You may have already watched our video about pharmacology and drugs. But if not, let's recap. What is a drug? A drug is a substance that when released into the body will cause an effect. Some are legal, some are illegal, and some are prescribed by doctors to treat illnesses. Whether a drug is legal or not, or can be bought without a prescription, varies by country. Recreational drugs are substances that people choose to take, like for example nicotine in tobacco, alcohol, or cocoa leaves in the Andes. In this video, you're going to learn about two different types of drugs and their effects on the body. The two types of drugs are stimulants and depressants. Why don't you pause the video here and try to guess the difference between the two? Stimulants give increased alertness and the speed of reactions, heart rate, and blood pressure. You can think of them as substances that speed you up. Stimulants also reduce a person's appetite. Caffeine, found in coffee, tea, and energy drinks, is a legal stimulant. Cocaine is usually an illegal stimulant and is highly addictive. As with most illegal drugs, taking too much can kill you because of an overdose. Cocaine dramatically increases your risk of a heart attack. Also, after taking cocaine, even just once, people will suffer what's called a come down. The user may feel depressed, have anxiety or panic attacks, hallucinations, or be unable to sleep. Cocaine is often snorted through the nose. If used long term, it can damage the nose to such an extent that the user can lose the septum of their nose. The second type of drug is depressants. They slow down reaction times, decrease inhibitions, damage brain cells, relax users, and make them more sociable. You can think of them as substances that slow you down. Alcohol is a depressant. Another common example is cannabis. It's usually smoked, but can also be baked in cakes and made into tea. Cannabis relaxes people, but it can make it very difficult to learn or concentrate. It can also cause users to become very paranoid, anxious, and sometimes psychotic. Smoking cannabis has been linked to mental health problems such as schizophrenia, especially if it's taken during the teenage years. Which organ system do you think these drugs affect? Most recreational drugs affect the nervous system. The nervous system is made of the central nervous system, CNS, which is the brain and spinal cord, and the peripheral nervous system, or PNS, which includes any nerves outside the brain and spinal cord. Neurons, or nerve cells, are specialized cells found in the nervous system. Can you label any of the cell structures in this diagram? Neurons carry impulses, or electrical signals, from one place to another in the nervous system. They connect receptors to the central nervous system, or CNS, and carry impulses back through the peripheral nervous system to effector organs, such as muscles and glands. To learn more about how the nervous system helps us sense the world around us, watch this video. When neurons are stimulated, they transmit an electrical impulse. They have many adaptations to make them as efficient at this as possible. Pause the video here and see if you can think of any adaptations. The axon is very long and carries an electrical impulse. It's covered by a fatty sheath made of myelin, which increases the speed at which the nerve impulse is transmitted. The nerve ending, or axon terminal, is branched to make good contact with many other neurons, or the effector organ. Two neurons do not make direct contact. Where they meet, there is a very small gap called a synapse. The impulse crosses the gap by means of neurotransmitter chemicals, which diffuse across the gap between the two neurons. Stimulants speed up synaptic transmission, while depressants slow it down. Some drugs stop the impulse from passing across the synapse completely. Drugs such as curare, the South American plant toxin used in arrow poison, do this. They cause complete paralysis and even stop the person from breathing. This substance used to be used in anesthetics, but obviously they had to use exactly the right quantity. Other drugs stimulate the synapse so that once an impulse crosses the gap, the impulse is repeated over and over again. One example is strychnine, a stimulant drug that comes from the same genus of plant as curare. It causes all the muscles in the body to go into a continuous spasm of contraction. In large quantities, it can stop the person from breathing. So now you know more about stimulant and depressant drugs. You have also learnt a little bit about the nervous system.
Under RA 9165, otherwise known as the Comprehensive Dangerous Drug Act of 2002, the term prohibited and regulated was changed into dangerous drug with the following classification. First, immediate precursors, a chemical substance used in the clandestine manufacturing process becomes incorporated in full or in part into the final molecules of controlled substances. Second, essential chemicals, chemical substance used as reagent or solvent in the illegal manufacture of controlled substances. Third, narcotic, psychotropic, and designer. According to pharmacological classification, first is stimulants, second is hallucinogens, third is depressant, fourth is inhalants. So, First is stimulants. Stimulants are drugs which increase alertness of physical disposition. Example is amphetamine, and the treatment of amphetamine are eye opener, lead poppers, pip pills, uppers, and hearts.
Go.
Next is shabu, and the street name is poor man's cocaine, S, shabu, ubas, siupaw, and sha.
Go.
Next is hallucinogens, are drugs which affect sensation, thinking, self-awareness, and emotion. Changes in time and space perception, delusions or false beliefs, and hallucinations may be mild or overwhelming depending on dose and quality of drugs. So for example is ecstasy. The street name is XTC, Adam, Essence, E, and Herbals. Next is depressant, a drug which depress or lower the functions of the central nervous system. Types of depressants. Narcotics, a drug which induce sleep or hypnotics or stupor and relieve pain or analgesic. Something that soothes or causes a sensation of mental numbness. This includes opium, opiates, heroin, morphine, and codeine. Next is tranquilizer, a substance that reduces anxiety, ease tension, and relax muscles. Sedative and hypnotics, calm the nerves, reduce tension, and induce sleep. For example is barbiturates and alcohol. So next is inhalants. These are any liquid, solid, or mixed substance that has the property of releasing toxic or psychoactive vapor or fumes. Example, solvent, glue, gasoline, kerosene, paint, thinner, and naphthalene.
It may seem common for young people to experiment with different substances, like vaping, weed, tobacco, Molly, and alcohol. Some may even consider hard drugs such as cocaine, meth, or opioids like heroin. Regardless of the substance, if it's not prescribed by a doctor and taken as prescribed, experimenting with substances can have negative effects. Meet Jeremiah. Jeremiah hangs out with his friends on the weekends. They drink alcohol and occasionally smoke marijuana to relax and get away from the stresses of life and school. One time at a party, Jeremiah smoked something a girl handed to him, not knowing what it was. Later, he found out that it was K2, a synthetic type of weed. His friends told him that he was hilarious and started acting crazy, and that they couldn't wait to party with him again. Jeremiah was concerned because he has no memory of what happened. He wants to be with his friends and have a good time, but he hated not remembering and doesn't want to take another substance like that again. He also feels new pressure to be the life of the party and act a certain way. What happened to Jeremiah is all too common. You start out taking one substance and end up taking something else. A danger in using any substance that isn't prescribed to you is not knowing exactly what it is you're taking and how it will impact you. Unfortunately, young people are being exposed to substances that can have dangerous physical and mental health consequences. As a good rule of thumb, if a drug isn't prescribed to you, you shouldn't take it. Pretty quickly, what feels like casual or experimental substance use can turn into a substance use problem, which has long-lasting and negative consequences. Before you decide to use a substance, know the risks and potential consequences, or reach out to a counselor to talk about it.
So our next topic is all about blood and blood stains. Why are blood stains useful for forensic scientists? Because blood behaves according to certain scientific principles. Trained blood stain pattern analysts can examine the blood evidence left behind and draw conclusions as to how the blood may have been shed. Composition of blood. It has 4 components: plasma, red blood cells, white blood cells, and platelets. Number 1. Plasma. Plasma is the largest part of the blood when separated from the rest of the blood. Plasma is a light yellow liquid. Plasma carries water, salts, and enzymes.
Go.
The main role of plasma is to take nutrients, hormones, and proteins to the parts of the body that need it. Cells also put their waste products into the plasma.
Go.
Number 2. Red blood cells. A type of blood cell that is made in the bone marrow and found in the blood. Red blood cells contain a protein called hemoglobin, which carries oxygen from the lungs to all parts of the body. Number 3. White blood cells. White blood cells are part of the body's immune system. They help the body fight infection and other diseases. Number 4. Blood platelets. Platelets or thrombocytes are small, colorless cell fragments in our blood that form clots and stop or prevent bleeding. Platelets are made in our bone marrow, the sponge-like tissue inside our bones. Bone marrow contains stem cells that develop into red blood cells, white blood cells, and platelets.
So I'm sure you know that blood is pretty important, right? I mean, if you see that someone has lost a lot of blood, it's not usually a good sign. But why? What is so important about blood? Well, in the next few videos, we will show you just how special this incredible red liquid is. Your blood is made up of plasma, red blood cells, white blood cells, and platelets. In this video, we will look at the red blood cell. These are also known as erythrocytes. And you have a lot of them. In fact, in just one drop of blood, there are about 5 million red blood cells. They only live for 120 days in your bloodstream, and every second, your body makes 2.5 million new red blood cells to replace old, dead cells. Okay, I hear you say, that's great. We have lots of these cells, but what do they actually do? Well, they have one very important function, and that is to transport oxygen around the body. Every cell in the body needs oxygen in order to carry out aerobic respiration and release energy. We take oxygen into our lungs every time we inhale, but something has to pick up that oxygen and carry it to all the other cells in the body. And that is the job of your red blood cells. And you know what? They do a very good job of it. And that's because they have all the special adaptations needed to carry out this very important role. Firstly, they have a biconcave disc shape. This basically means that they look like a jam donut that has been squashed in the middle. This gives them a large surface area to absorb oxygen very quickly. Another adaptation is that they have no nucleus. Think about it. There would be no use in a red blood cell taking up extra space with a large nucleus when it could use that space to carry even more oxygen. An amazing adaptation. But the best adaptation of all is that they contain the transport protein hemoglobin. In the lungs, it binds with oxygen to become oxyhemoglobin. As the red blood cells travel around the body, they release this oxygen from the oxyhemoglobin to the respiring tissues. But there is more. Oxyhemoglobin is also what gives the characteristic red colour to the blood cells. You can see that red blood cells are very special cells. Did you know one of the world's biggest killers, the malaria parasite, invades and destroys blood cells, and that's why it's such a serious disease to get. And yet, although they are so important, red blood cells make up just one part of your blood. Of course, we've got more lessons for you on the other parts. A quick question to see if you've been paying attention. How many red blood cells has your body made during the last 2 minutes of this video? Pause the video now while you work it out and click play when you're ready for the answer. The answer is 300 million cells. Give yourself a pat on the back because that's a lot of cells.
The 3 confirmation tests for blood that determines whether something is really blood are. Number 1 is microscopic test. Number 2, microchemical test or microcrystalline test. And number 3 is spectroscopic test. Microscopic test for blood smear test. A laboratory professional examines the slide under microscope and looks at the size, shape, and number of different types of blood cells. These include red blood cells, which carry oxygen from your lungs to the rest of your body. White blood cells, which fight infection. Next is microchemical test or microcrystalline test. Microcrystalline tests are chemical tests resulting in the formation of unique microcrystals for a given substance. When combined with a specific reagent, microcrystals are observed under a microscope, and micrographs or microvideos constitute the result of the test. The last one is spectroscopic test. A spectroscopic test method is described whereby the percentage oxygen saturation of hemoglobin within intact corpuscles can be determined. A complete oxygen dissociation curve can be determined with 1 to 2 cc of whole blood. Next is Steakman test, a confirmatory test for blood based on the formation of distinctive hematine crystals that are viewed under a microscope. The reagents typically used are sodium chloride and glacial acetic acid. Next is the Aston test. Ketones in blood test measure the level of ketones in your blood. Ketones are substances that your body makes if your cells don't get enough glucose or blood sugar. Glucose is your body's main source of energy. And the last one is the spectroscopic test for blood. A spectroscopic method is described whereby the percentage oxygen saturation of hemoglobin within intact capsules can be determined. A complete oxygen dissociation curve can be determined with 1 to 2 cc of whole blood. Spectroscopy is a class of tests which study the interaction of sample specimens with energy, usually in a form of light. And that's all for today. Thank you and God bless.